Welcome to the US EMV Value-Added Reseller Qualification Program's educational webcast series, brought to you by the Payment Security Task Force and the EMV Migration Forum. Hi, I'm Stuart Miller from FEAM, and I'll be providing a brief on the US market EMV, the big picture. Why should you support EMV at all? Why is EMV chip necessary, and why now? There's a lot of questions. The thing is that EMV migration is not just about security. It's also about migrating to a global standard that not only offers better security, but it's a baseline for new products and solutions coming into the market, like mobile payments. The US is the last major market to broadly adopt EMV, and recent breaches are testimony to the increased security threat that the US payments industry is facing. And EMV is a critical step that we should take to further secure the payments industry. The main key reasons for migrating to EMV are security and fraud. EMV brings increased security and reduced counterfeit fraud for card-present transactions by replacing static magnetic stripe data with EMV chip technology. It's the only globally interoperable standard for card payments. EMV also brings crypto protection to card-present transactions and protects against stolen data being used by a criminal for in-store fraud. For future innovation, leverage for innovation in mobile payments, for example, NFC contactless. For global standard and interoperability, using EMV helps ensure that US cardholders who travel abroad enjoy global payments interoperability, as do international cardholders who travel to the US. Customers and merchants experience fewer fraud events. This builds trust and reduces the operational costs of fraud management. US travelers should experience fewer card acceptance problems when traveling to EMV chip-enabled countries. Similarly, visitors to the US should enjoy an improved acceptance experience. By that I mean a higher probability of approval due to implementation of US terminals with chip technology. What is the liability shift? How does it work? How does it differ between payment networks? Why and how does it impact you? And is migrating to chip required? Liability shifts are being introduced by different payment networks to encourage accelerated adoption of chip technology in the US, thus making paying safer. Today, across payment networks, liability for fraudulent transactions in store is generally the responsibility of card issuers. Beginning October 1st this year, the major US payment networks plan to implement fraud liability shifts that will impact who is responsible for counterfeit chip card transaction and or lost or stolen chip card transactions at the retail point of sale. The details of liability shifts for each payment network may vary. As of that date, liability for those transactions will shift to the merchant in certain cases if the merchant has not implemented EMV chip-enabled devices and applications to process EMV chip payment transactions. Liability shifts for ATM and automated fuel dispensers will take place at later dates, depending on the particular payment network. The counterfeit liability shift works by shifting responsibility for certain fraud transactions from the party that invested in EMV technology and to the party that did not. The EMV Migration Forum will publish a white paper soon, understanding the 2015 US fraud liability shifts, which will summarize each payment network's liability shift requirements, which will be available on the EMF Knowledge Center webpage. If deploying an EMV solution in the US, what are the key considerations for the US market? How are these different from other countries, for example, Canada and Europe? Well, first, the US market is different from other EMV markets due to its large size and fragmentation, the regulatory requirements, and the legacy infrastructure. The most important message is to start planning for EMV migration immediately if you've not already started. There is a substantial EMV learning curve which has a US perspective. US regulation requires that an issuer provide at least 2 unaffiliated network routing choices to the merchant for US issued debit cards. This requires an EMV solution for the US. The EMV Migration Forum has published a definition of technical EMV debit framework in the white paper, US Debit EMV Technical Proposal. It is available on the EMV Migration website forum. Also refer to the debit webcast for more details. Legacy systems may need significant change to accommodate EMV rather than an incremental upgrade. The pace of change in the US EMV migration appears to be comparably faster than in other countries. This may result in the need to manage many projects in parallel. Consider that the implementation challenge for each merchant may be different, depending on the merchant's system configuration. Evaluate whether a semi-integrated solution can be used instead of a fully integrated solution. Not all merchants require a fully integrated solution, and it can speed up the merchant migration. The EMV migration hosts a Evaluated Reseller Training Day in September 2014. The recorded sessions and presentations are available on the EMV Migration Forum website. How does EMV help prevent fraud? The main reason for fraud reduction is preventing the reuse of cardholder data, typically in counterfeit cards and online fraud. The main types of theft of cardholder data are theft from systems that store cardholder data, from visible data embossed on the card, from the card magnetic stripe. EMV creates a unique cryptogram for each transaction. Cardholder data is difficult to extract from the card-present EMV transaction and difficult to reuse for in-person fraudulent transactions. What is the outlook for fraud over the next 2 years? Global migration statistics suggest the value of EMV technology in reducing counterfeit fraud. Countries like UK, Canada and Mexico have migrated to EMV and have experienced a reduction of counterfeit fraud in a range of 50 to 80%. What is this multi-layered approach? A multi-layered approach extends cardholder data protection using a combination of EMV chip cards, tokenization and encryption. Tokens are derivations of the cardholder data that are difficult to reuse, such as acquirer tokens and issuer tokens. On the acquiring side, acquirer tokens enable the cardholder data to be securely stored. Encryption is the process of encrypting payment data in a secure terminal and transmitting it through an internal or external network, where it is decrypted in a secure environment. It is currently used in parts of the US payment card industry and can be used alone or with tokenization and chip. Industry standards such as the PCI Data Security Standard call for the encryption to protect data at rest and at any time card data is transmitted over a public network. Encryption can be initiated at the beginning of a transaction to protect data from being compromised inside of a merchant environment by malware or other means. What is your current exposure to fraud, and can this look different over time? Experience of other countries suggests that when EMV is implemented, criminals seek to attack less secure non-EMV merchants. Aren't there other technologies, mobile, Apple Pay, that are better, cheaper? Should I prioritize mobile, NFC contactless, over EMV contact chip? How does Apple Pay leverage chip technology? What are the technological commonalities? EMV is the foundation for a more dynamic and secure payments infrastructure. It's not just about cards. Some NFC-based mobile wallets, notably Apple Pay, are utilizing EMV security features today. These mobile wallets leverage the same underlying dynamic cryptogram used in EMV chip card payments that is unique with every transaction. Acceptance of Apple Pay requires the enablement of NFC contactless technology. The good news is that there are new terminals available with NFC contactless readers built in. Merchants should consider leveraging the opportunity to not only enable contact chip, but also contactless chip technology, given that the hardware will be present. We encourage merchants to complete contactless certification at the same time as contact chip. Apple Pay uses compatible technology. Apple Pay uses NFC technology, which supports EMV standards and is a global standard. Since Apple Pay leverages the same payments technology, Apple Pay and EMV can be implemented at the same time. How does migrating to EMV vary by major industry vertical or segment? For example, retail, restaurants, gasoline, quick serve. Industry verticals have different acceptance requirements due to their specific environments. The requirements of these verticals vary considerably. Some options suit specific environments better than others. Retail may prefer terminals that stand alone and are semi-integrated or fully integrated according to their size and environment. Portable wireless terminals may be useful in remote and restaurant environments. Each vertical may require or suggest particular types of transactions be supported. For example, pre-authorization may be necessary at a hotel for check-in. Deferred authorizations may be needed when host connections are unavailable, for example, in-flight purchases or locations with periodic outages. Cardholder amount entry or confirmation may be necessary. It's useful to refer to the payment network requirements for details on particular transaction types. EMVCo has a best practices document on recommendations for EMV processing for industry-specific transaction types, which is a guide that can assist you as well as payment network guidelines. There is a development preparation session which will also provide more details. Will magnetic stripe still be supported in the US? For how long is it expected to continue? Will the US be 100% chip-on-chip by October? The US will not achieve 100% migration of chip cards and chip terminals by October 2015. The percentage of chip-on-chip transactions will increase mostly in the early stages of the migration as points of high-density transactions migrate. Points of lower-density transactions will take longer, as a larger number of systems need to be migrated. MagStripe will continue to be supported for the foreseeable future, and that it continues to be supported in every market that has migrated to EMV. Each payment network will need to decide when it will retire magnetic stripes. How do the PCI Security Standards Council and the EMVCo work together? The PCI Security Standards Council and EMVCo have different perspectives and scope of influence, but they both seek to make the payments industry more safe and secure. They collaborate for that purpose when feasible. EMVCo focuses on common standards across participating payment networks, which enable the payments industry to operate on a common cardholder device and terminal technology. The PCI Security Standards Council focuses on security practices for protecting payment account data. EMV chip has strong security features that have been proven to reduce counterfeit card fraud at card-present retail environments. The PCI Data Security Standard, PCI DSS, provides other complementary levels of security necessary when the account data reaches the merchant's system. The PCI DSS consists of 12 key technical and operational requirements. Rather than focusing on a specific category of fraud, the PCI DSS seeks to protect account data everywhere within the payment ecosystem, thus limiting the availability of this data to fraudsters. When used together, EMV chip and PCI DSS can reduce fraud and enhance the security of the payments ecosystem. In closing, consult with your acquirer and payment network for more details on their implementation requirements. Thank you.